Hello everyone, welcome to the new video of Data Analytics. Today's video is about parametric test. We have already completed the requirements of a questionnaire, that is reliability statistics, normality assumption and validity requirements. After that, we have to check what are the statistical tests necessary to prove the objectives of the study. First of all, we have to look for what is parametric test and what are its assumptions and what are the different types of parametric test. Here it is. We have to move for the video. In this video, we have to cover introduction, meaning and assumptions, different parametric test and the conclusion. The part 1, that is introduction. Yes, we can say that parametric statistics is a branch of statistics which leverages models based on fixed or finite set of parameters. Parametric tests are the type of statistical test used to analyze data that follows a specific distribution, usually normal distribution. The normal family of distribution all have same general shape and are parameterized by mean and standard deviation. It means if the mean and standard deviation are known and if the deviation is normal, probability of any future observation lying in a given range is known. Parametric statistics was mentioned by R.A. Fisher in his work Statistical Methods for Research Worker in 1925, which created the foundation of modern statistics. This is about introduction of parametric test. That is moving to part 2, meaning and assumptions. First of all, look for the meaning. A parametric test is a statistical method that assumes sample data comes from population following specific distribution, usually normal, and relies on population parameter like mean and standard deviation, making them powerful but sensitive to assumption violation. Parametric test is a statistical test which assumes parameters and the distribution about population are known. It uses mean value to measure the central tendency. It is also defined as distribution-based test dealing with the assumption that population data are normally distributed. Moving to the assumptions, the very important assumption is that normality. The data should follow normal distribution. Parametric test estimate population parameter like mean and rely on properties of normal distribution for accurate probability calculation. The second assumption is that homogeneity of variance or homozydicity. The variance of the data should be equal variance across all groups being compared. Then independence of observation is the third assumption. Each data points or observation within and between groups should be independent of all others. Continuous data, that is interval or ratio, is the fourth assumption. The dependent variable must be measured on continuous scale, that is interval or ratio scale, not categorical. And the next assumption is no extreme outliers, no extreme values that lie far from main body of the data. It heavily influences mean and variance. Yes, we are moving to the part 3, that is different parametric test. Yes, we can see here t-test, ANOVA, correlation and regression. The first one is t-test. A t-test is a statistical tool used to determine if there is a significant difference between means of two groups. It calculates a t-value, which is a ratio of the difference between group means to the variability within the groups. A larger t-value means a greater difference relative to the data scatter, suggesting significance. If the p-value is small, we reject the null hypothesis, that is no significant difference, or conclude it means truly difference. Different types of t-test. One sample t-test. It compares the mean of single sample group to a known or hypothesized value. That is, does average test score equal to 80? It helps to decide if your sample data likely came from the population with that specific mean or if there is statistically significant difference. Next is two sample t-test, or otherwise known as independent sample t-test. It compares the means of two separate unrelated group, that is the test score of group A versus group B. Third one is paired sample t-test, that is dependent sample t-test. It compares the means of same group at a different time or conditions. It may be assessed through before or after approach, or without approach. The next parametric test is ANOVA. ANOVA, or analysis of variance, is a statistical test used to compare the mean of three or more groups to determine if there is statistical significant difference among them. There are one-way ANOVA or factorial ANOVA that may be two-way or three-way, etc. One-way ANOVA compares the mean of three or more independent groups based on single dependent variable. Factorial ANOVA examines how two or more than two independent variables and the interaction between them affect dependent variable. Moving to the next parametric test, that is correlation. Correlation measures the strength and direction of linear relationship between two or more variables indicated by a coefficient, that is R, between -1 and +1. There are positive or negative correlation, low, moderate or high correlation, perfect or zero correlation between variables determined according to the coefficient value. It measures the significant relationship between or among the variables using different hypotheses. The next parametric test is that regression. It is a method of analysis, explains cause and effect relationship between independent and dependent variables. It helps to predict unknown dependent variable using one or more independent variable. It may be simple linear, multiple linear, polynomial or logical regression. The value of regression coefficient measures the changes in dependent variable for a 1 unit change in independent variable. Let us move for the last session, that is conclusion. Yes, parametric tests are the powerful tool in statistical analysis, allowing the researcher to make inference about population based on sample data. These tests assume that data follow a specific distribution, typically a normal distribution, and provide estimate of population parameter like mean and variance. The key benefits are it's more powerful. Parametric tests are generally more powerful than non-parametric tests, meaning they are likely to detect real effect if one exists. Precise estimate. They provide accurate estimate of population parameter, enabling informed decision making. Wide applicability. Parametric tests are widely used in various fields, that is including science, social science and engineering. These are all about parametric test and its assumptions, different parametric tests used. Okay, if you have any doubts, please comment below. Thank you for watching.